Guys, in this video I'm going to show you the steps in drawing the dot and cross diagram for covalent substances. Let's look at the first example, carbon and fluorine. So first of all, both carbon and fluorine are non-metals, so they will chemically combine through sharing of electrons to form covalent compound. Before you draw the dot and cross diagram, it's always good to write down the electronic configuration. So for carbon is 2, 4, and then for fluorine it is 2, 7. So what it means is that carbon is short of 4 electrons. So if it is short of 4 electrons, it means that it needs to share 4 pairs of electrons. 4 pairs of electrons in order to achieve noble gas electronic configuration, a stable electronic configuration of a noble gas. So for fluorine, it is short of 1 electron, so it needs to share 1 pair of electrons. So when you draw the dot and cross diagram, always draw the valence shell first. So share 1 pair of electron with a fluorine atom, and then you would need to share another pair of electron with a second fluorine atom, and then carbon need to share a third pair of electrons with a third fluorine atom, and finally it need to share a fourth and a final pair of electrons with a fourth fluorine atoms. So now you need to double check the valence shell. Okay, fluorine should have 7 valence electron in its valence shell. So in all the 4 fluorine atoms here, they only have 1 electron each on its valence shell. Let's assume that cross is the valence electron for fluorine. Is the electron for fluorine. So only have 1. So each of these fluorine circle only has 1 cross. So you need to draw the other 6 crosses, because total there should be 7 crosses, 7 electrons on the fluorine valence shell. Okay, how about for carbon? Okay, the dots are the electrons for carbon. So carbon should have 4 valence electrons, 4 dots. Correct. So carbon and fluorine, the valence shells are correct. So now let's look at the inner shell. So each fluorine atom should have 2 electrons in its inner shell. Okay, it's not very nicely drawn because I'm using the touch screen. And then for carbon, likewise, there should be 2 dots, 2 electrons on its inner shell. So this would be the dot and cross diagram for the compound form between carbon and fluorine. So again, the first step, write down the electronic configuration. Second step, draw the electrons, draw the shed electrons. Third step, check the valence shell. Fourth step, the inner shell. Let's look at the second example, oxygen and chlorine. So again, first step, write down the electronic configuration. For oxygen, it is 2, 6. How about for chlorine? 2, 8, 7. So what it means is that oxygen need to share, it's short of 2, right? Short of 2 electrons, so need to share 2 pairs of electrons. Chlorine need to share 1 pair of electron. So when you draw the dot and cross diagram, so now it's the second step, which is to draw the shed electrons. So oxygen and then chlorine, because oxygen needs to share 2 pairs of electron. Chlorine need to share 1 pair. So 1 pair and then another pair. Okay, the shed electrons are correct. So second step done. Third step, check the valence shell. So oxygen should have 6 valence electrons. So let's assume that dots are the electrons for oxygen. It should have 6 dots. So in this diagram here, there are only 2. So which means that you have to draw 4 more. Okay, so total 6 dots. How about for chlorine? 7 crosses. So in this case, each of the chlorine only has 1 cross. So which means that you have to draw 6 more. 6 more here. So valence shells are correct. So third step, valence shell. So now is the final step, which is the inner shell. So oxygen, the inner shell should have 2 electrons, 2 dots. How about for chlorine? Chlorine, there are 2 inner shells. The first electron shell, 2 electrons, and the second electron shell, 8 electrons. So first electron shell, second electron shell. Okay, again I'm using touchscreen, so you should be able to do a better job than me. So likewise, first shell, second shell. So this is the dot and cross diagram for the compound form between oxygen and chlorine. Thank you for watching. Bye bye.